says find the horizontal asymptote, please look at the degrees of numerator and denominator. If you find that the degree of numerator is less than denominator, then the answer is always going to be 0. That is in terms of limit x tends to infinity, the answer is 0. And if somebody says what is the horizontal asymptote, answer is y is equal to 0. If the degree of numerator is greater than denominator, please keep this in your mind that we are not going to have a horizontal asymptote. In this particular case, horizontal asymptote will not exist. Simply put, limit x tends to infinity also does not exist. Third condition is if the degree of numerator and denominator is found to be equal. For example, if I say question is 3x square minus 4 upon 7x square minus 2x plus 4. The resultant answer in this case, if I am finding horizontal asymptote or I'm finding limit x tends to infinity, would be just the ratio of these leading coefficients. That is, the remaining terms will not have any importance. Only divide the leading coefficients 3x square by 7x square. The x squares cancel out. You're left with 3 by 7. So what's your horizontal asymptote here? Y is equal to 3 by 7. Now I said there is a concept of limits also coming to picture, right? We have questions of limit in the examination, and I'm sure most of the students sitting in my classroom may not be aware of what limit concept is, right? So when somebody says that find limit extends to a, again the focus is on a rational function px upon qx. I'll give you my quick method. You're not supposed to learn all the hackles of calculus in this. You can do a simple work. Check is q of a equal to 0. If q of a is not equal to 0, then the answer of this question would be p of a upon q of a. That is, simply put the value of a into the expression and get the answer. Matter is done, right? If you find q of a is equal to 0, please go on to check p of a. If you find p of a is not equal to 0, then please remember the limit will not exist because this is a condition of vertical asymptote effectively, right? As I told you, for a particular value, if the denominator is 0 and numerator is not, we get vertical asymptote. Vertical asymptote means limit x tends to a does not exist. Condition 3 is you find that denominator is 0 already and the numerator also is equal to 0. In this case, we will have a hole, right? And when there is a hole, we will have a limit. Now the point is, how do I find a limit? A school teacher will tell you a typical method of factorization or some formulas. My best method is that please understand when somebody says limit extends to a, he wants you to keep the value of x close to a but not equal to a. So why not do a simple work task with the calculator and put some value of x which is close to a and trying to find what is happening. For example, if I say x minus 2 upon x square minus 4, and if somebody says find limit x tends to 2. So I'm sure you'll agree that if you put x equal to 2, you get a denominator as 0. And if you put x equal to 2, you get a numerator also as equal to 0. So as I told you earlier, the limit is going to exist. So the mathematical concept that is taught to you in the school is to factorize the numerator and denominator. So that becomes x minus 2 into x plus 2, right? And the cancellation leads to a fraction as 1 upon x plus 2. And now I'm sure you'll appreciate I can put x equal to 2 simply and get the answer as 1 by 4. But if I don't know there is nothing wrong in it, you can pick up the calculator. What does the question say? Limit x tends to 2, right? So the value of x has to be close to 2, not equal to 2. Let's put the let the calculator do the work and put the value of x as 2.01 and check what answer you're getting. I'm sure you'll get the perfect answer near to the very final answer, right? So that's the best way of finding the limit in a perspective of a ACT paper. Kindly use this. That's the best method I can advise you right now. And this is flawless method, always yields proper results. But please check first thing, what I told you already, right? When I say limit extends to a, p of x upon q of x, the condition for limit to exist is that either q of a is not equal to 0, or if q of a is equal to 0, then p of a also should be equal to 0 at the same position. Then the limit will exist. Else the limit will not exist. Uh, then, of course, I talked about the concept of equations of circles and ellipse, right? Do we get a question on that? Also, very frequently, you get an equation on circle and ellipse question. Uh, the equation of circle, I'm sure most of my students sitting in this session right now know about it. X minus h whole square plus y minus k is equal to k whole square is equal to r square, right? Based on the concept that we have a center h comma k, and any point on the circle is going to have a distance of r from the center of the circle. So that's why this formula comes into picture, right? Whereas a ellipse is talked about, ellipse is a little bit different. So when somebody says ellipse, we have two orientations of ellipse, either x oriented or y oriented. You can see actually it's an extended circle. It's a circle which has been pulled like this or pulled like this, right? So in an ellipse, we have two axes which can pass through it horizontally and vertically and divide this into two equal parts, right? We can have one like this and one like this. So I'm sorry for the quality of drawing, right? The logic at work for us is going to be simple. That these two lines, which is, I'm also I'm sure you'll agree that there is going to be only one horizontal line and one vertical line that can do it, right? You cannot have multiple horizontal lines doing for you. So the point where these horizontal and vertical line intersect is what is called the center of an ellipse. This is h comma a, sorry. And the distance from here to here, you can see this is one distance and this is one distance, right? And in this case, this is the same distance set, but in this case, this is longer, this is shorter. In this case, this is longer, this is shorter. The nomenclature says always take the longer one as A and the shorter one as B, right? Now that's what the nomenclature says. Calculator may not require it that way, but again, that's for learning phase. Please remember that this is going to be A, this is going to be B, and similarly, this is going to be A and this is going to be B for you. So based on the analysis and the conditioning, the formula of an ellipse comes out to be x minus h whole square upon a square plus y minus k whole square upon b square is equal to 1. Whereas in this case, it becomes x minus h whole square upon b square plus y minus k whole square upon a square is equal to 1. Traditionally, again, every ellipse that we talk about has a focus also. There are two focuses on it. The distance between the center and the focus is given by the value c, and the value of this c is actually given as under root of a square minus b square. Now, I'm sure you will agree that we have an equation of circle and we have an equation of an ellipse. They both look similar, right? And actually, they are similar. If a square and b square become equal, right, then the ellipse becomes a circle, right? So vice versa theory also comes into picture, and this leads to a small formulation which says to me that if I have a area of circle formula is pi r square, right? So area of an ellipse is pi ab. That looks similar, right? And if I say the circumference of a circle, we say the formula is 2 pi r. Here the circumference is pi times the a plus b. So again, you can see a set of formulas which are very close. In fact, circles and ellipse are very close to each other. Now, one unfortunate perspective that had to be kept in mind while dealing with this is that we do not get equations always in the standard form of ellipse and circles. We get the equation which are expanded. Which are expanded means they end up looking something like this, right? Let's say some form of equation which will look like uh, px square plus qy square, sorry, plus let's say gx plus fy plus c, right? So what is it? Equation has been expanded, right? Which equation? Either this or this has been expanded, and the equation will look like this, right? I'm sure you'll appreciate this will be a biquadratic equation. Biquadratic in a sense that there will be a term of x square also, there will be a term of y square also. Now the question is this equation going to represent a circle or an ellipse? The answer is it depends on two methods. One is you can convert the equation of the standard equation into the equation of an ellipse or circle by completing the squares. Again, I'm sure most of my students understand that when I use the word completing the squares, what I mean by this. So when I say convert this from this form to this form or this form, that totally depends on your skill set. But there is one basic observation that I would like to share with you, that I look at this equation like this, and somebody asks me comment on it whether it is equation of a circle or an ellipse. My logic at work is very simple. I look at the coefficients of x square and y square both, right? If the coefficient of y square and x square are equal, that is p is equal to q, right? I understand this is the equation of a circle. If I find that p is not equal to q, right, then I have a simple theory and both are positive or both are negative, right? Although this is rare, both are positive, then this will represent an ellipse. I hope you understand the reason. The reason lies behind this only, right? The thing below is unequal here, where there's a thing below them is one each, right? So this is equal here. So that's a basic foundation behind this theory. Uh, Similarly, we have to do a bit of rectangular and polar coordinates also, right? So rectangular polar coordinates again are very popular nowadays in the examination. Yeah, you tend to get a question set normally very frequently on this, and this is what is differentiated between the 35 and the 36 always in a ACT paper. So when I say rectangular and polar coordinates, the logic at work is we are normally used to writing every point in the rectangular form, right? That is x comma y, right? So when I say x comma y, that is 3 comma 4, right? So that point, that representation ends up as a rectangle, right? So obviously you're moving 3 units like this, 4 units like this, vice versa, and you get to this point, right? So this is 3 comma 4 for you, right? So rectangular coordinate. Similarly, polar coordinate looks in the form of r comma theta. Now when I say r stands for the distance of the point from the origin, right? And when you join that point with the origin, it always makes an angle theta with the x-axis in the anti-clockwise direction, right? I hope you know the standard anti-clockwise direction is positive, clockwise is negative for us, right? So this angle theta is what is theta here, right? So r represents the distance of the point from the origin, and theta represents the angle that the axis that the line makes with the x-axis. Line joining the point with the origin makes with the x-axis, right? So here, for example, if I say pi comma 60 degree, please remember r stands for phi and theta is 60 degrees. So point would be somewhere here. I hope you can see one thing very immediately for yourself, that this point doesn't seems to be a unique point in a sense that I can say this is representing 5 comma 60. I can also say it is 5 comma 420. Means I can have a complete circle and come back to this point and I can say this is 5 comma 420. Or I can also say that this is 5 comma minus 300. So what I mean technically is that as x comma y is unique, right? If I say 10 comma 3 comma 4, that's a unique point. You cannot write 3 comma 4 anywhere else. But in rectangular polar system, you can write the polar system, sorry, you can write the same point in multiple ways, right? That means you can say a point as 5 comma 60 is same as 5 comma 420 is same as 5 comma minus 300. So you do get a question in the examination where you have to check that which of the following option is the same as this of this point, right? So the process starts by converting a polar coordinate to a rectangular coordinate, right? When I say polar to rectangular means what? Let's understand this carefully. If I have a point r theta, right? If I say represent this in a rectangular coordinate system, I'm sure you'll agree that if this was rectangular point, this was going to be x coordinate, this was going to be y coordinate. So you can see clearly that x upon r is nothing equal to but cos theta and y upon r is nothing but equal to sine theta. So I can say in the rectangular form, x would be equal to r cos theta and y would be equal to r sine theta. So in this area also, what I was saying to you was that you pick up the calculator and check it out. Convert 5 comma 60 degree into rectangular by doing this, right? And then check the options, each of them with the same process and see which gives the same answer as 5 cos 60 comma 5 sine 60. And here being good in trigonometry helps you drastically. Trigonometry is going to be important backbone. Otherwise, calculator is always a friendly thing for you. Um, As far as converting reverse way is concerned, if you say convert a point 3 comma 4, that is in the rectangular form to polar form, then I'm sure you would remember r, as I said, is the distance of the point from the origin, right? So r stands for under root of x square plus y square always. Correct. And of course, at the same time, if somebody says what is theta, I always advise my students to visualize the point carefully. If the point is in the first quadrant, like 3 comma 4, right? So x is 3, y is 4. So I'm sure you'll appreciate theta is nothing but 10 inverse 4 by 3. What happens if the point goes to the second quadrant? Let's say the point is minus 3 comma 4. Then I always tell the students don't worry about anything else. You make a triangle, first of all, a rectangle triangle. And then remember this angle is alpha. So theta is actually nothing but 180 minus alpha. And again, you can see theta alpha is still going to be equal to 10 inverse 4 by 3, right? Signs do not play an important part. Sign would be omitted. So my answer would be what? My answer would be 180 minus 10 inverse 4 by 3. Same way, third quadrant, if somebody says 180 plus 10 inverse 4 by 3. And if it goes into fourth quadrant, that is 3 comma negative 4, it will be 10 inverse 4 by 3 still with a 360 minus. So that's what the polar rectangular coordinate system is. And the same is used for describing a vector also in component forms and everything. Uh, Very occasionally you get questions on logical maths also. That is also you should take care of it, right? That should be understood by you. And then of course inequalities play a havoc sometimes in a paper. So all in all, if you talk to me personally, question number 51 to 60 is normally advanced topics questions, especially coming from the topics which are a surprise. Students get questions on vector resultant of vectors also. Student gets questions sometimes on parallelogram law of vector addition also. So when I say advanced mathematics, in ACT, it's a broad umbrella. It is not constrained or restricted umbrella like a SAT paper. ACT paper will always be having more variety of questions. But the good news is you may not have a perfect knowledge about it. You just need to have an understanding of the topics. So the bottom line is you should be aware of the topics when it comes to advanced mathematics. And the more the topics you're aware of, the more are your chances of getting the questions and the scores correct, right? Again, reminding you back, right? This is the last session of mathematics. I'm just trying to remind you back, friends. Don't forget, we're looking at a 60 question, 60-minute paper. Your strategy plays a very important part. Your negative marks also play a very negative marks in the sense that if you get it wrong, you also play a problem. So please understand the entire ACT paper focuses on 2 points. One is speed, and the second is accuracy. And the third thing which I normally emphasize in is also the knowledge, the content part, right? I should be knowing more and more topics in mathematics to ensure a perfect score of 36. Second thing is, please don't forget that time management is a critical tool. Just giving you quick concept that I use for time management in the ACT paper is that in the first 30 minutes of the paper, I should be through with at least 40 questions of the paper. Some of the students are so amazingly fast that they say, sir, I finished the math section in 30 minutes. I always tell them, for God's sake, don't do that stupidity, because ultimately, if a paper is given you 60 minutes, you need to spend 60 minutes on the paper. Don't spend 60, spend 45, spend 50, but don't do it in 30 minutes, right? Don't try to uh, post a situation back to ACT people that they are actually having a paper which is easy. And don't forget that if the paper is very easy, it is easy for everybody in the country. So eventually in the world practically, right? So when I say that if the paper was easy, then the only ticket or the only surety that you can have in a paper is to score a 36, is to get all 60 correct. And last thing, uh, my observation, all my students who have been high scorers in ACT have been high scorers in ACT because maths has contributed in their scores a big way. English, will always have limitations. Science also you'll have limitations, right? Writing, reading, everything has got their own limitation. But maths, there is no limitation as such because the paper is easy, but the only problem is it covers more and more variety. So that is it from my side, and I hope this would have been a simple, fun ride for all of us. We have tried to be through with a lot of topics. Thank you very much, sir. Thank you very much from my
Yeah,
side.
so that was a really superb session. Got to notice one point is although you develop all the skills to understand the concept, but you need to be very much very specific with the ACT exam perspective, like the things wherein like you could use the thing you were talking about limits, wherein you do not factorize and cancel it out. You can just substitute. So there was very much small detailed tips.
It's just a basic thing. Depth is not required. You should know the topic. That's what ACT more focuses on. So that's what I'm emphasizing again and again. Knowing them is also enough. It's not a rocket thing. Just knowing them is enough. They'll survive.
Okay, okay. Thank you so much for this session. And to all the students, stay tuned for the next session. See you at 6. Thank you,
Thank
sir.
you. Thank you.